60,000 years ago, in what is now South Africa, someone dipped the tip of an arrow into a plant extract and waited. They didn't know what chemistry was. They didn't know what alkaloids were. They had no concept of pharmacology or toxicology or any of the frameworks we use today to explain why certain plants kill things. All they knew, all they needed to know, was that this specific plant, prepared in this specific way, applied to the tip of this weapon, meant that an animal struck by the arrow would slow down, would stumble, would eventually collapse, not from the wound itself, which might be too small to kill directly, but from something invisible in the plant that entered the bloodstream and did what the hunter needed it to do. They had figured out how to weaponize chemistry 60,000 years ago, with no written language, no laboratory, no teacher, only observation, experimentation, and the accumulated knowledge of people who had been watching the natural world kill things for a very, very long time. In January 2026, a team of researchers from Stockholm University and the University of Johannesburg published a paper in the journal Science Advances confirming what had long been suspected. Quartz arrowheads recovered from Umhlatuzana rock shelter in KwaZulu-Natal, South Africa, dated to 60,000 years ago, contained chemical residues from Buphone disticha, a toxic plant still used by traditional hunters in southern Africa today. This is the oldest direct chemical evidence of poison weapons ever found, and it pushes back the known history of human chemical warfare by more than 50,000 years. Today, we are talking about how ancient humans discovered poison, how they figured out that the natural world was full of invisible killers, how they learned to identify, extract, and weaponize those killers, and what that discovery ultimately did to human society. Because the story of poison is not just the story of a hunting tool, it is the story of knowledge becoming power, and what happens when certain people decide that power should only belong to them. Before we talk about when ancient humans discovered poison, we need to establish something important. They didn't really discover it. It was already everywhere. The discovery was not the existence of poison, it was the recognition of what it was and what it could do. The natural world is saturated with toxic chemistry. Plants produce alkaloids, glycosides, and terpenes specifically to deter the animals that eat them. Mushrooms synthesize compounds that destroy liver tissue. Frogs concentrate toxins from the insects they consume until their skin becomes lethal to touch. Snakes, spiders, jellyfish, cone snails, a significant portion of the animal kingdom has independently evolved chemical weapons. The reason so many different creatures developed poison is simple. It works. It is extraordinarily effective at killing things faster than they can fight back. Ancient humans were immersed in this chemical ecosystem from birth. Their entire existence was organized around the question of what was safe to eat and what wasn't. And answering that question was not just a matter of avoiding death. It was a prerequisite for surviving at all. The human brain evolved several mechanisms specifically for navigating this toxic landscape. The most fundamental is taste. You carry approximately 25 different bitter taste receptors on your tongue, the TAS2R family, that evolved specifically to detect plant alkaloids and trigger an immediate aversive response. When something tastes sharply, intensely bitter, your instinct to spit it out before swallowing is not culturally learned, it is genetic, it is ancient. It is your body's first line of defense against a world full of things designed to kill you if you eat them. But taste alone was not enough. Many of the most dangerous substances have no strong flavor. Some are deadly in quantities too small to taste. And many plants that are toxic raw become safe when cooked, or are only dangerous in certain parts, or are harmful to adults but tolerable to children, or vice versa. The complexity of the problem required more than instinct. It required observation, and ancient humans were extraordinary observers. One of the most consistent findings across studies of modern hunter-gatherer groups is that they watch animals. Specifically, they watch which animals eat which plants and which animals die or get sick afterward. If a monkey eats a berry and thrives, that is evidence in favor of the berry. If an antelope grazes on a specific plant and then staggers, stops, and collapses, that is information. That is the beginning of a database that gets richer and more detailed with every generation that adds to it. Ancient humans were not stumbling blindly through a dangerous world. They were systematically building knowledge about it, knowledge passed down through story, through demonstration, through the direct instruction of children who would carry it forward. And crucially, they had time, tens of thousands of years of continuous occupation in the same landscapes. Continuous exposure to the same plants, the same animals, the same seasonal patterns. Each generation added to the database of what was safe and what was lethal. Each accidental poisoning that didn't kill, that merely made someone violently ill, became a data point. Each observed animal death became information. The knowledge accumulated slowly, imperfectly, at enormous human cost, but it accumulated. By the time ancient humans were deliberately weaponizing poison 60,000 years ago, they had already been building the foundational knowledge for hundreds of thousands of years before that. Knowing that a plant is poisonous is one thing. Deciding to put that poison on an arrow is something else entirely. The conceptual leap between those two things is enormous, and it tells us something remarkable about the cognitive sophistication of ancient humans. Consider what that leap requires. You need to understand, first, that the thing that makes the plant dangerous is a separable property, something that exists in the plant and can be extracted or transferred. You need to understand that this property can persist outside the plant on a different surface, in a form that still functions when it enters an animal's body through a wound rather than through digestion. You need to understand that a wound too small to kill directly can still be lethal if it delivers the right substance. And you need to be able to hold all of that in mind while planning a hunt that may unfold over hours, understanding that the effect of the poison will not be immediate, that the animal will continue to move after the strike, and that you need to follow it and wait. As lead researcher Sven Isaksson of Stockholm University put it when the 2026 study was published, understanding that a substance applied to an arrow will weaken an animal hours later requires cause and effect thinking and the ability to anticipate delayed results. It requires a developed working memory. It requires abstract reasoning about things that are not directly visible. This is not a simple cognitive task. It is, in fact, one of the more sophisticated pieces of applied reasoning that any animal has ever demonstrated. And it was happening 60,000 years ago in southern Africa by people who had no writing, no schools, and no science. How did it happen? The most likely answer is accident, followed by observation, followed by intentional replication. An animal is struck by an arrow in a hunt. The wound is not fatal. The animal should escape. But it doesn't. It slows down unusually fast, stumbles, becomes disoriented, and eventually stops. The hunter examines the arrow that struck it. They examine the animal. They notice something. The arrow had been resting against a particular plant, or the hunter had been handling that plant before the hunt. Something from the plant got onto the arrow, and whatever it was, it helped. This observation gets filed, gets remembered, gets shared, gets tested again, deliberately this time, with the arrow placed against the plant before the hunt. The result repeats. The knowledge crystallizes into practice, and the technology that will persist for 60,000 years and counting has just been born. The specific poison identified on the 60,000-year-old arrowheads from Umlatusana rock shelter is derived from Boophone disticha, a bulbous plant known locally as gifbol, which in Afrikaans translates directly as poison bulb. Gifbol is a remarkable plant. It belongs to the Amaryllidaceae family and produces a cocktail of alkaloids, primarily bufotenamine and distichamine, that affect the central nervous system and the cardiovascular system simultaneously. In sufficient doses, it causes paralysis, respiratory failure, and death. In smaller doses, it causes profound sedation and disorientation. An animal struck by an arrow coated in gifbol extract would not die from the wound, it would die from the chemistry. It would slow down, lose coordination, and eventually become unable to move, at which point the hunter simply walked up and finished the job. What makes this discovery particularly striking is that gifbol is still in use today. Traditional San hunters in southern Africa still use it as arrow poison, applying preparations from the bulb to their arrowheads in methods that have almost certainly changed very little over tens of thousands of years. The knowledge of this specific plant's properties, which part to use, how to prepare it, how to apply it, has been continuously transmitted from generation to generation for longer than most human civilizations have existed. The continuity is staggering. The arrowheads from 60,000 years ago and the arrows being prepared by traditional hunters today are not separated by a gap in knowledge. They are connected by an unbroken chain of human transmission, parent to child, elder to young hunter, generation to generation, across 60 millennia of history. That chain of transmission is itself one of the most remarkable achievements in human prehistory. Knowledge about which plant, prepared in which way, produces which effect, kept alive through oral tradition and practical demonstration for longer than agriculture has existed, longer than writing has existed, longer than any institution that humans have ever built. For most of prehistoric history, poison was a hunting technology. It made small hunters capable of killing large prey. It extended the effective range of weapons. It compensated for the physical disadvantages that a relatively small, slow, clawless primate has against the large animals it needed to eat. But at some point, we cannot say exactly when, but the evidence suggests it happened very early. Someone looked at the poison on the arrow and thought a different kind of thought. Not, how do I use this to bring down a wildebeest? But how do I use this against that person? The transition from hunting poison to warfare poison is one of the darkest and most consequential moments in human prehistory, and it required almost no conceptual innovation, only a change in target, the same plant, the same preparation, the same arrow, just aimed differently. Archaeological evidence suggests that, by at least 10,000 BCE, humans were using chemical weapons against each other, dipping weapons in poisons before raids and territorial conflicts. The logic was the same as hunting. A wound that might not be immediately fatal becomes reliably lethal if the right substance enters the bloodstream through it. An enemy struck by a poisoned weapon may escape the immediate confrontation, but will not survive long enough to matter. This introduced something new into human conflict. Before poison, warfare was a test of strength, speed, and numbers. Poison changed the equation. A single small person with a poisoned arrow could neutralize a much larger, stronger opponent. The advantage of physical size and strength, which had been decisive in almost every conflict in evolutionary history, could be bypassed entirely by chemistry. This was, in the most literal sense, the invention of chemical warfare, and it happened not in a modern laboratory or a military research facility, but on a hillside in ancient Africa, tens of thousands of years before any civilization we usually associate with the concept of warfare. Here is the part of the poison story that almost nobody talks about, and it may be the most consequential part of all. Poison knowledge is not like fire knowledge or tool-making knowledge. Fire, once discovered, spreads. Tool-making, observed and practiced, can be replicated by anyone with enough time and the right materials. But poison knowledge, knowing exactly which plant, which part, prepared in which way, applied in which concentration, produces which specific effect, is detailed, specific, and easily kept secret. And in ancient societies, keeping it secret was extremely valuable. Researchers studying ancient tribal cultures across Africa, the Americas, and Southeast Asia have noted a consistent pattern. Knowledge of toxic plants tended to be concentrated in specific individuals, specialists whose status in the group was directly tied to their exclusive access to this knowledge. The person who knew how to prepare the poison that protected the group's hunters, that could neutralize a rival group's warriors, that could treat or produce certain kinds of illness. That person had a form of power that was unlike any other form of power available in a pre-technological world. You could not outfight the poison specialist, you could not outrun their knowledge, and you absolutely could not afford to make them your enemy. This is almost certainly one of the origins of what we now call the medicine man, the shaman, the witch doctor, figures whose social authority rested not on physical strength or hunting ability, but on specialized knowledge of the natural world's invisible forces. Forces that could heal or kill, forces that operated beyond the visible and the immediately explicable, forces that, to people without the explanatory framework of chemistry, would have appeared indistinguishable from magic. The poison specialist was not just a hunter's assistant. They were the person in the group who could touch the invisible and direct it, and the mystical aura that surrounded them, the fear and reverence they inspired, was not superstition. It was a rational response to genuine documented power. In this sense, the discovery of poison may have done something far larger than improve hunting efficiency. It may have been one of the first forces that created differentiated social roles, individual specialization within human groups. The first profession, in a meaningful sense, was not the hunter or the farmer. It may have been the person who knew what the plants could do. So, how did ancient humans discover poison? They didn't discover it. It was always there. What they discovered was how to read it, how to observe what the natural world was already doing, killing things through chemistry, and understand that this was a resource, not just a danger. 60,000 years ago, in a rock shelter in South Africa, someone put a toxic plant extract on an arrowhead and changed the history of human hunting. The same plant is still in use today, an unbroken chain of knowledge, 60 millennia long, transmitted from person to person through story and demonstration across more time than most of what we call history. From that first poisoned arrow, the knowledge grew. It became a weapon against prey, then against rivals, then against enemies. It became the exclusive property of specialists whose social power rested on secrets too dangerous to share. It became the origin of the medicine man, the shaman, the alchemist, all the figures throughout history who derived their authority from knowing what the invisible world could do to the body, and eventually, through thousands of years of accumulated observation, experimentation, and documentation, it became toxicology, pharmacology, medicine, the entire scientific and medical framework that today lets us deliberately harness the chemistry of the natural world to heal rather than harm, traces a direct line back to those 60,000-year-old arrowheads in a South African cave. Every medication you have ever taken, every antibiotic, every painkiller, every anesthetic, all of it traces back through an unbroken line of human curiosity about what the natural world's poisons could do, to a moment 60,000 years ago when someone dipped an arrow into a plant and waited to see what happened. They had no idea what they were starting, but here is what they did know in the most practical and immediate sense. The natural world was full of invisible forces that could kill. That knowledge, not feared but studied, not avoided but harnessed, is the foundation of everything that came after. Every medicine, every toxin turned therapeutic, every vaccine that uses a weakened pathogen to train the immune system, all of it is the same intellectual move that an ancient hunter made 60,000 years ago in a South African rock shelter. You observed what killed, you learned its properties, and then you decided which direction to point it.